Hello students, welcome back. Let us resume our discussion in section 1. Previously, we went through the method of substitution. Find the simplest term, solve for that variable in that equation, and then put it into the other equation, or substitute it into the other equation. What if you do not like that method? Well, here's another method called elimination, and this is a method preferred by computers because it's easier to program. Nowadays, of course, computers can handle substitutions too, but in 1950s, 60s, 70s, the programming languages were far more rudimentary, so it was easier to program this way, and it was easier to make it completely algorithmic. And also, it can make our computation easier as well in some cases. How do we work it out? All right, let's eliminate a variable. Which variable to eliminate? Let's eliminate x first. So I want to get same 2x. So multiply 2x to the second line. Multiply 2 to second line, so we get 2x. Multiply 2, multiply 2, and then if you subtract 2x minus 2x, that's going to be gone. So that's how you do substitution. So subtract 2x, 2x gone, 3y minus 8y, I have negative 5y, and then be careful here, 6 subtracted by negative 2, 6 minus a negative 2, that's the same as 6 plus 2, so it's 8. Therefore, y is 8/5, negative 8/5. That's how you get an answer. So multiply a certain number to entire row so that we get same term, and then if you do subtraction, then you can eliminate it. Or equivalently, you could have multiplied negative 2 right away, and then you could have added, as I did here in my answer key. Multiply negative 2 to each and then add them. And then what I just did is multiply just 2 and then subtract it. Which way do you like better? It's about the same. Our textbook author apparently prefers this. Multiplying negative 2 to begin with so that you can add them up so that you have less to worry about when you do the final addition. If you do subtraction, and if there are too many negatives flying around, that can cause confusion for each column. So yes, I agree with the textbook author's method. So I usually go with multiplying by negative number and adding instead of multiplying and then subtracting. Let's do one more practice. This time, let's remove y to find out x. What do I multiply to make them equal? Well, if you cross multiply, you can achieve that. Multiply 4 to the first line, multiply 3 to the second line. Want to see? Multiply 4, so 8, multiply 4, 12, multiply 4, all right? Now down here, multiply by 3. Multiply 3, multiply 3, and then what do you get? 12y, that's common. So you can subtract to remove this 12y. Shall we do that? Subtract 8 minus 3, so 5x. Subtract 24 subtracted by negative 3. 23 minus of negative 3 is 27. And that can cause a bit of a confusion, you see. And it works fine. But this subtraction, that can cause confusion. So what if we just multiply negative 3 to the second line, or after getting this, instead of doing the subtraction, prepare subtraction by all those preparation, change sign, change sign, change sign, which is equivalent to multiplying by -1, and then you add them up. Oh, wrong key, sorry about that. And then you add them up, and then of course you get the same result, no surprise there. And this way you can cut down some unnecessary mistakes. So you can directly multiply by 4 to the first line and -3 to the second line, and then add them up, or get them the same and then do subtraction, or get them the same and then get one extra step to change those signs and then add them up. Taking a long way around, but it's an effective way to cut down mistakes this way. It's your call. Our textbook author's way is to do it this way. Multiply by appropriate negative integer and then add them up. Let's do one more practice. Let's see. Remember this problem? Yeah, this one is a bit too simple. We have lone y here. That's a bit too simple. So let's go ahead and do it. Let's go ahead and do the second problem. Let's see. Would you like to try this without any help? Stop the playback and go ahead. Did you get your answer, or did you try and give up? Okay, all right. Let's remove one variable, and which is easier to remove? Looks like removing y is easier because 2 times 2 is 4 right away. So from here, multiply 2 to entire first line. So multiply by 2, multiply by 2, multiply by 2. And then you can go ahead and subtract. But oh boy, to subtract, too many negatives are flying around. So further preparation, a sign change, multiply by -1, multiply by -1, and multiply by -1. Okay, now let's add. This way, a bit less confusion. Yes, I took a little bit longer way, but it's a surefire way to cut down mistakes. So 6x plus 2x, we have 8x, and then y part is gone, and then 2 plus 3 is 5. I get x is 5/8. All good? Okay, that's your x. How do you find your y? Okay, let's copy and paste this thing. Let's cross multiply to remove x. Multiply 2 to the first line and multiply 3 to the second line so that we get the same thing here and there. Okay, multiply by 2. Multiply by 2. Oh, excuse me. 3 times 2 is 6. Multiply by 2. Alright, next. Multiply by 3. Multiply by 3. Multiply by 3. Okay, alright. Now you can add them up. That'll kill off this x part. And then you have 4y plus 12y, so 16y. And then -2 plus 9. 9 minus 2, that's 7. Y is 7/16. This kind of method is called the method of elimination. Which do you like better? Our textbook is written in terms of substitution first, and then we do elimination. And to tell the truth, I've seen many textbooks in both high school level and college level, and ever since I arrived in United States, substitution first, substitution, and then elimination comes way later. That was the standard order here in the United States. I don't think I remember seeing an exception. By the way, I studied these things when I was younger in South Korea. There, in the standard textbook, elimination shows up first. So I learned elimination first and then learned substitution later. And as a matter of fact, I agree with that. For most of those systems of linear equations with integer coefficients, elimination is easier. We have plenty of time left, so you see, elimination is easier, so it's shorter, doesn't involve as many computations, so we have a lot of time left. Let's talk about this one here. And then don't be intimidated by all those decimal expressions. Removing all those decimals by shifting it twice here, because this one has 2 decimal digits, that's the maximum, so shifting twice will do. How do we do that? Multiplying by 100. Multiply by 100. Multiply by 100. And then you can simplify this thing further, because look at the first line. Everything is divisible by 5. Oh, wait a minute. Instead of 5, this should be 15. Why? Sorry about that. Yeah, we started from 15. So divide by 5, I'm going to get 70 divided by 5 is 14. And then 15 divided by 5 is 3. And 24 divided by 5, you can do that with your calculator. If you want to use mental math, multiply by 2 and then divide by 10, that's equivalent to dividing by 5. You can check. 24000 divided by 5, yeah, 4800, and that's precisely what we have here. So that's the system, and then do your thing, and then you'll be able to find x and y values. Let's see, do you have enough time to complete it? I don't know. Let's see, multiply 14 to those to the second line. So that's it, isn't it? So 1000 times 14. No, too many zeros. You see, that's the defect of any kind of mental math. Please check your computation from time to time to cut down those kind of mistakes. Okay, all right. And then I can do subtraction, but one way to do the subtraction is to put extra negative sign. So put negative here, and then that becomes negative, and that too becomes negative. And then if you add them up, 14x, negative 14x, that part will be gone, and you're going to get only 28 minus 3, so 25y equals to that. So 92 y is 9200 divided by 25. Punch that into calculator. You're supposed to get 368. And then you can do something similar to x, removing y. Yeah, multiply 2 to the first line, multiply 3 to the second line, and do your computation, and you can get your x like that too. I'll leave the detail to you. We went through the elimination method.